And in outer joins, there are like three kinds of outer joins. There are like the full outer join in which you get all the rows from the both tables. The left outer join is like you get all the rows from the left table, and the ones like which are intersecting with the left table from the right table. And that's just the opposite in the right outer join. I'm going to go over the queries that will make more sense. So this is, I created tables, basically two tables to like go over this exercise. So you have the addresses table. So in the address table, okay, let me go over the person's table first. The address tables. Okay. So in the person table, you have, there's a person table, you have the first name and the last name. There are only two people in this table, and the person ID is one, and the other person ID is two. So there are two people, and this person ID like identifying the person. And then you have the addresses table, which is, this is how it relates to the person table. You have the person ID column in this table as well. And you have three IDs, but if you remember, like the previous table just had like two people ID, like one was one, the other one was two. In this case, it's just 2, 3, and 4. So there's only one person who is common in the table. So that person is in the first table, the person's table, and his address is in the second table. And the person ID is the one which is common between the table. So if you want to, let's do a query on this. So if I wanna, and the thing about PG admin is like I have these open right here, so I can see like what columns are present in each table. So I'm gonna use that to write my query. Select star from persons is my, so I'm just doing a select star from persons, and then I'm gonna do a join on the addresses, with the addresses table on the person ID column. So it would look like this. Let's see, let's try it out this. So, like I said, that there was only one person which is common between the tables. So Bob Sanders was in the people table, and it had the person ID 2. And in the addresses table, you had the person ID 2, and you had the city and state as New York, New York. So what I did right here is it's just select star from persons. I'm like pulling everything from persons, but I'm joining with addresses. And since it's just a join on this, and I'm just joining by, so it's just checking the column person ID in both the tables and seeing if where the person ID which is common in both the tables is just like pulling that out. So that's why it's an intersection. It's an inner join. And right here, I just wrote the column name, because the column name, when I was creating the table, I kept like different column names. But most of the time, you have the same column name, just to like, in when you have like lots of tables, if like one table is related to the other table with like user ID or something, it would most probably be the same column name. So then you would have to like put which tables column you are referring to, so that it does understand that, because it would have the same column name. So this is how like you would refer to like which I'm referring to this table's column. I want the relationship on this table's column with this table, with this other table's column. So I'm just gonna make sure that you know this too. So same result. So if you have like different column names, you can just say like person ID equal to person ID. In this case, like the capital letters were different. But if it's the same column name, it's better to like put the table name in front of it, so that like whoever is reading the query when it's running as well, like you can like differentiate. So this is what inner join is. Now, if we want to do a left join, so left join is basically, let's go back to the picture. So the left join is basically like I want everything from the person's table and the intersection with the addresses table. So I would write it like this. The first part would not change. I would have the left join part. So basically, when you write a left join query, when you put the left join, like the keyword, the table on the left, which is the person's, is on the left side. Think about it this way. And the table on the right side is the one on the right side. So it's going to pull everything from the person's table. So you'll have I think Bob Sanders and Alan Wang, like you would have both those rows, and then it's doing a left join on the addresses on the same column. So let's see what we get. So we have like both these people, but we get null for this person because we didn't have the address information for this person in the addresses table. But basically we get like all the rows from the left table. That is this is what a left join is. Now if we do a right join on this, what we get is, so a right join is again like the table on the left is on the left side, the table on the right is on the right side. So what we will get here is like all the rows in the addresses table, but intersecting with the ones on the person's table. So everything on the right side and the intersection. So it would look like this. So we have everything from the addresses table, but you get like null for where we didn't have a person for this on the left table. That was a person's table. And for one, we had the details, like we have it like filled up, right? And the last one is like full outer join. Full outer join is like you get everything from both the tables. So I think for that we have the.
Yeah, so before jumping into that one, just to highlight what's here below, notice, right, we of course we have all the address rows, but there are some like people rows that are missing, right? These are the people rows, I'm guessing, that like, for instance, like beyond Bob Sanders, I think there's like Alan Wang, right? He's not showing, right? Why? Because the right outer join only says we have to show all the rows with the addresses, but it doesn't say we have to show all of the corresponding rows, right, with people, right? So what it's doing is just showing all the rows with addresses, and then when there's a match, it shows the match. When there's no match, it still shows it, but it just puts in null values. You all follow that? Cool.
Yeah, and then outer join, like, oh, am I not using the right keyword for outer join? Oh yeah, it's full outer join. So this would like make more sense. So in the full outer join, like we have all the rows. So we have rows from the people table. These are the first two. And we have the rows from like the addresses table. And then this is the intersection row. So if you remember the first query that I ran, which was the inner join, it just had this particular row number 2. That is it. So outer join is like everything. You can see like the intersections that we got earlier. So the inner join is the middle row, and then left outer join was basically row number 1 and row number 2. So we had both these two rows from the people's table, and it obviously intersected with this one. While the right outer join, in that we had the last 3 rows. So we had the 3 rows from the addresses table, and we know that it intersected with the people table. I see 2 questions. Why double quotes and column names? This is very specific to PG admin. I have to put like double quotes because that is how it understands like capital letters, and it's able to differentiate. Okay, this is the column name, and this is the table name. This is the column name. It's not necessary. It's very specific to PG admin and Snowflake. Snowflake also has this issue. You have to put it in quotes for it to like identify the capital letters, because in industry, like we do, like it's important to like account for like we use that to like identify stuff. Like in this case, like the person ID, we would have a column name like this actually. In what instance an outer join would be helpful? I haven't seen too many cases. Is this used a lot?
You mean I guess you mean a full outer join, Mia?
A full outer join. So these joins, these joins are used. These joins are very useful. If you're talking about the full outer join, I would say it's more useful to see what's up. I joined 2 tables, and you're seeing them as a single table.
And you're seeing all the records, right? It's like if you want to get a sense of all the records with both tables, right, and not have anything excluded, right? So for an example, like think about what information this potentially provides you. Well, we have some like parent, we have some individuals, like the name information, and then we have some address information, right, with missing data. But probably all of them were users at one point, probably. I don't know. So this might give you a sense of like, hey, these are the total number of signups we have, but we're just missing some information in some columns and other missing information, right, in the other columns from a different table.
So basically the full outer join is basically saying select all from both tables.
Mm-hmm.
Yes.
Everything.
But over this column. So that column is like what it's like matched against. But
Right.
it's selecting everything from both the. So okay. Nothing. Like you have the address ID, you see the person ID, because I'm doing a select star from. So right here you can like choose which columns you want to display as well. Like I just want to display persons dot first. Wait, this is PG admin. I would have to. So I want to display the first name, and I want to display the city. Let's see. So it look like this. And generally, like what happens is like when you like start working with these SQLs, like again, like on that question, you would write like longer queries. You would be joining like multiple tables together and like trying to find insights in there. So you would maybe do an outer join first and then like find the intersection. So that's where it comes handy. Otherwise, like there's one useful in the reading, you'll find this. Like I have created the query right here for that. But it's basically in the reading, it's like find all the total number of people in there, number of people with addresses, number of people without addresses. This is the query like which gives you that. So basically count is an aggregate method in SQL, and what it does is it just counts like the non-null values. So this is where like left join is coming handy. So when we are doing a left join, so you have everything from the persons table, right? So you have those 2 rows from the persons table, and for one person there is addresses as well. The address is also there. So what it's doing is in those 2 rows, it's just counting. It's doing a count star, so you get like 2 rows because it's not null. And then like it does the address. It does a count on addresses dot person ID, and there it sees like one of that is null and one of that is not. So it gives a result as 1 here. And then you're just doing a subtraction on both these to get the persons without addresses. Does it make sense?
Right, so this is just for me to clarify. Like so the first column, obviously it has like total number of rows.
This is what it'll look like, the result.
Right.
So and then when you do count star on this, it's gonna count like both these rows. But when you do a count star on addresses dot person ID, it'll see like 1 is null and 1 is not null. So that's why the result is 1.
When you do a count address ID, right? You're saying when you do a count, right? So you're doing because it's just.
So I'm just doing it over this column.
Yeah, right.
So
exactly.
And it just counts for null. So this is what I removed earlier. Yeah.
Yeah. So
it's just.
Sorry.
So because now it doesn't make sense. Like I had to do all this. I had to find like total number of people, persons with addresses, persons without addresses, and did it in like one single query. And this is where like left join comes handy. Like because I want everything from the persons table. So I got like everything from the persons table, and I did a left join with the addresses table. So it just has like 1 row from the addresses table. So because only Bob Sanders had an address. And then for total number of people, I'm just doing a count star on the table. So I'm getting 2. And then for the for finding which people have the address, I'm doing the count star on this column because the person ID, that capitalized small d is from the addresses column. And what count does is just counts the non-null values. That's
wait, not a count. Just wanted to make this very clear. Not a count star, right? You're doing a count like of just that column. Right.
And so I could have done addresses.city too,
Right.
And it would have given me the same result.
Exactly.
Like any column on the addresses side. And all this I could do on one query because I first formed that, it went missing. I first formed that table with the left join, right? The result with the left join. And then I did those count thingies on this. So it's a step-by-step process, if you think. Any questions?
Can you show that last query again? I just want to make sure I get this. So the first one, right, is count star. So that counts the total number of rows. Then the second one, right here, you're just counting on a single column. So the advantage, right, with the single column is that it's only counting the present values, the non-null values. So if you look in the person ID column, there's only one non-null value, right? That's this number 2 that you see. So that's why it gives you a result of 1. And then for the other one, now we're saying, okay, show me all the rows that don't have, the first one is the second one is all the rows that do have addresses. That's count addresses.personid. The third one is show me all of them that do not have addresses. So that's the total number of rows minus the ones that do have addresses equals the ones that don't have addresses, right? It's like a little trick, kind of, right? Show me the total minus the present equals the missing values for addresses, right? So if I have five rows, 3 of them have addresses, that means that 2 of them do not, right? So we count
just a subtraction on the above
exactly,
2, right?
Right.
Total people minus the people without addresses. This is just to I wanted to show this query just to show you how important these joins are, and that's why they ask in the interviews when you want to gather multiple tables together and do a number of things in one query. It's very useful. I don't think I have anything else now for joins. Jeff, do you have anything else?
No, I think that's it. So you can see it, in the readings. I think I accidentally deleted some of the queries, but they're at the bottom of the Jupyter notebook of the Colab when you look at it. And also Apurva went through basically, a good number of them, if not all of them. So it's you can do this outer joins, and then the next 2 problems are some interview questions that you can look through, and then from there you can move on. Give them a shot. You can Google them probably, or we can go through them, and then the Python interview question set is the next thing to tackle. How I understand it, we have to run this, and then we have to load our data, and now we can look. These are the user IDs, and this is the web page they visited. And then this is the user IDs and the mobile page, right, that they visited. Now, the one thing to note is that you can have, a user visiting multiple pages. So it's what's the grain of the data? Well, this is each web page visit, right? Not each web page user. So the first step we can do, so it says, okay, find the percentage of users who have visited the website 1 or more times, but who have never visited on mobile. Okay, so this is unique website visitors. And then those, of those who where are there not even one mobile visitor, okay? So for unique web users, we can do, you could do a group by, you could do a group by user ID, but I think for right now, we can just do select distinct user ID from web users, right? Because if we do select all from web users, notice we get 2021 rows. If we do select distinct of the user ID, so the unique user IDs from web users, right? Then we get 1256 rows, right? So it seems like users are basically visiting 2 pages, right? A little bit less than that on average. And then what you can do is we can wrap this, right? We haven't gone through subqueries, which is fun for you. But you can, the way I like to do a subquery is first write out the query, check that it works, and then literally wrap this in parentheses, and then just do select all from. So you're selecting, this is a table, basically that you have as a result, and then you just select all from this resulting table, and you can call this something like unique web users, something like that. And then we can also now do the same thing. So these are my unique list of web users. What if we got the web users, right, the percentage of users, the web users who have never visited on mobile? So what does that mean? That means we want all of the web users, but then we also want to find kind of, now maybe we can do a left join on the mobile users, and that will give me, every row here will have a present value because these guys all visited, but then I'll have some null values on the mobile users, right? So I'll at least be able to look at the data and see, okay, this is a web user who hasn't visited on mobile, etc. How do you do that? Well, it's kind of similar, right? We want to do select distinct user ID from the mobile users as unique mobile users, right? And but I need to join this stuff, right? So let's join this. So we're joining our unique list of web users, join the unique list of mobile users on, and we'll separate this into kind of multiple lines, on the unique web users dot user ID equals unique mobile users dot user ID, right? So I want all of the web users, and then I want to link each of the web users up with the mobile user, and that's because the percentage of users who have visited a web page, so all of the web users, but we need to see those who have and who have not visited on mobile for now. Okay. So if I do this, this is I'm doing join, aren't I? Nobody corrected me. We should do left outer join, right? Because I want to show, because currently with an inner join it's showing the values that match up precisely, but if I do a left outer join, it'll show all the web users and show the people that do and do not match up as mobile users, which will be nice. Okay, so now you can start to see this. Let's do a limit 10 or something. Might look a little bit better. Okay. So this guy, he visited on both pages, both mobile and web. And I'm going to call this, I just want to name my columns a little bit. I apologize. So that we'll call this unique mobile users user ID as mobile visitor. And then actually before that, we'll do unique web users dot user ID as web visitor. Okay, so yeah, all of the web visitors should be present, right? These are all, we want only all the web visitors. And now here we've identified a web visitor who did not show up on mobile, or who did not, a web visitor who did not attend on mobile. Okay, so now we're pretty close, believe it or not, I think. Right, I can at least see the answer. If I wanted to, if we only had 10 rows here, we could count it up and calculate it. That's how you that's how you typically know you're on the right track, is if your brain can start filling in the rest, then typically you can translate that into code. So what does that mean? The next thing I might do is count this, right? Count the web users, and then count the mobile users, right? Because that would tell me the total web users and total mobile users, and I'll expect this one to be smaller, right? This would be my mobile only. So we can do that. Let's do that in a new query. We'll just copy this. And we'll do select count of the web visitor, select count of the mobile, and this is amount web, and then amount, this is actually, yeah, this is amount of mobile and web, I guess, right? We'll just say amount mobile, right? But these are mobile users who have also visited the web, and we need to take away the limit 10. Okay, and and the first thing I'm doing is like, especially if this is like using real data, is confirming that this just like looks right. So one, this number should be bigger than this one, right? Because we know these are, we have all the web users, and there's some of the mobile users. Some of these web users have not visited on mobile, so this is good, right? And then the percentage seems about right. I don't know, like it seems feasible to me. The other thing that's nice is, let's go back to the question. Okay, percentage of web users that are not mobile users. Yeah, this seems, because we have the answer, this is starting to line up. It almost looks like this divided by this, right? But it's all, right? This would be 7% probably. So, you can start to do 1 minus it, perhaps. So let's build up to that. So the first thing we can do, we can just copy and paste this. So this will be, if we just do it divided by, right? Not divided by, right? It's amount mobile divided by the amount web, which I think I did it wrong. So this is the amount mobile divided by the amount web. Let's just take a look. Select count, unique mobile, right? Unique mobile users. So this is the amount of mobile users divided by the total web users, okay? And I'm pretty sure this isn't going to work, but let's just try it. Yeah, and it gives us 0, right? And the reason why, it also gives us this long thing. The reason why is because it's like rounding down, basically. Like, what we have to do is tell it to use the percentage. And one trick for that is multiply this by a float. I think you won't probably only need one of these to be multiplied by a float. Like, let's just try multiplying this by a float, and then it will allow the result to be a float and not just an integer. And I wasn't right. Let's multiply both of them. I might have to do, yeah, let's do both of them. Okay, now we're on our way, right? Because we got 76%. Let's give this ugly thing an alias. So this is as percent. What is this? This is the percent of mobile users. This is the percent of mobile users of web, or you can put it this way: the percent of web users who are mobile. Right? And I broke it. I put this in the wrong place. This should go right here, sorry. Let's undo. Oh no. Sorry about that. I'm just trying to go backwards. What did I mistake? Select 1.0, count star. Let's read the error message. No such column unique web users dot user ID. Count unique web users dot user ID as unique mobile users. Oh, I removed this alias. Unique, sorry about that, web users. Okay, so we're back to where we were. The only thing I was trying to do was just to add an alias. That should come right here, right? As percent web who are mobile. Okay, now we give it an alias. And you can round it or whatever. So now this is the percent web who are mobile. So now what is the percent web who are not mobile? Well, 76% are mobile. So the percent that are not mobile is 1 minus it. Okay? So you can take this whole thing and do 1 minus it. And let's just make sure we get the answer right. Okay, that looks good. And then just add the word not. Or not mobile. Okay? And that's as good as I can do. Okay. But the key thing for me Like, there's no way I can write this out all at once, or maybe well, one, I don't think I can, and then two, I certainly wouldn't trust myself to, right? I definitely not in an interview, and probably not solo either. So, but what I can do is like break the problem into steps, and the more you press shift return and like make it visual, like already this problem became easier, and then it's like, what's the next logical step? Probably count them up and start getting closer to the answer, and then just get closer until you solve it. That's really what I recommend. So, yeah, I'll take questions in a second if there are some, but I did post this so you can start to see like my thought process, or I think what most people's thought processes might be, and that's what I'd recommend doing, is just go through those steps and see if you can replicate that approach if you weren't able to solve this. How does that feel? Feel all right? Yeah? You sure? Okay. All right. See, this is definitely hard. And not only is it hard, but we also didn't cover everything to go through it. We have like 45 minutes left. I would say go through